In the sense modalities, in the previous video we have learned the visual sensation, and this video we will be learning the auditory sensation. In our environment, various sounds are there. To detect, identify and recognize and to understand the sound is very important for us to fit in our environment. It allows us to adapt in our home and in the society. And it allows us to communicate with others more easily and efficiently. So, before going to the details of the auditory sensation, please remember to subscribe and share the channel. Thank you. What is audition? Audition is the act of hearing a sound in response to acoustic waves or mechanical vibrations acting on a body. So, simply it is the act of hearing a sound, audition. Then, auditory stimuli. It is the stimuli that are or may become the sources of sound. So, sound waves are the auditory stimulus. This stimulus enter our ears. Then auditory sensation. The human response to the presence of the auditory stimulus and its basic physical characteristics of sound intensity, frequency and duration. So, stimuli are present in our environment. Sound waves are the stimulus and these sound waves are recognized by our sense organ, that is our ear. The three basic auditory sensations are loudness, pitch and perceived duration. The auditory perception. So, as in any other process, the sensation process, here also the stimuli is there. It is sensed by our sense organ and then we need to give a meaning to it. For that, perception is needed, auditory perception. So, it is the interpretation of the auditory stimulus. Anatomy of the auditory system. Our ear, it is divided into three sections. The outer ear, the middle ear and the inner ear. The outer ear includes the pinna. It is a visible part of the ear. It protrudes from our head. Then the auditory canal and the tympanic membrane or the eardrum. So these three, the pinna, the auditory canal and the tympanic membrane, it is included in the outer ear section. Then comes the middle ear. It contains tiny bones known as the ossicles. These three bones are the malleus, incus and stapes. So these three togetherly known as the ossicles, it is the middle ear section. Then comes the inner ear. It is the enlarged diagram of the inner ear portion and the inner ear contains the semicircular canals. It is involved in the balance and movement of our body. That is a vestibular sense. And it includes, the inner ear section includes cochlea. So it has semicircular canals and cochlea. The cochlea is fluid filled and it is snail shaped. This structure contains hair cells. They are the sensory receptors of the auditory system. So, the inner ear section contains cochlea, and this cochlea contains the basilar membrane and the hair cells. Hair cells are the sensory receptors. How it works? Let's see. The sound wave, it travels along the auditory canal. So the sound wave, it travels along the auditory canal. Then it strikes the eardrum or the tympanic membrane. And when the sound wave hit the eardrum, it vibrates. These vibrations result in the movement of the three ossicles. That is, in the enlarged diagram we can see this. So this is the eardrum. When the sound wave come and touch the eardrum, then this eardrum vibrates, and this vibration result in the movement of the ossicles, that is the malleus, incus and the stapes. This get vibrated and the stapes is pressed into the thin membrane of the cochlea, and this is known as the oval window. So the vibration makes the stapes press into the oval window. The fluid inside the cochlea, it begins to move. So the oval window also get vibrated and it makes the fluid inside the cochlea makes to move. And when the fluid moves, what happens? There are hair cells or the auditory receptors inside the cochlea. This will get stimulated. The hair cells or the auditory receptor cell will get stimulated. The basilar membrane is the thin strip of tissue within the cochlea. So inside this basilar membrane is the auditory receptors, and this auditory receptor cell get activated when the fluid get moved by the vibration of the oval window. The auditory cortex. So the hair cells or the auditory receptors in the cochlea in both the ears, when it get activated, it generates neural impulse, and these travel along the auditory nerve to the brain. So the neural impulse travel along the auditory nerve to the brain. The auditory nerve, it sends message to the thalamus, both the right and left thalamus, and from there it is sent to the auditory cortex in the brain, and it is in the temporal lobe of our brain. Similar to the visual system, here also it is evidence found that the information from both the ear is sent to both the halves of the brain. It is not like the left cochlea sent message to the right brain and right cochlea sent message to the left brain. It doesn't work like that. But both the ear, from both the ear, the message is sent to both half of the brain, and the process is done in parallel streams. So from cochlea, the nerve impulse is traveled to the thalamus and then to the auditory cortex, and there the perception happens. Pitch perception. Different frequencies of the sound waves are associated with difference in our perception of the pitch of the sound. The high frequency sound waves are perceived as high pitched sound. The low frequency sound waves are perceived as low pitched sound. So we perceive the frequency as pitch. The audible range of sound frequency is between 20 and 20,000 Hz. The unit of the loudness of sound is decibel. For example, an ordinary conversation is approximately equal to 60 decibels and a rock concert is approximately equal to 120 decibels. So these are examples of different levels of sound loudness in daily life. The lowest of the human hearing range is approximately equal to a whisper at a distance of 5 feet. So the frequency is perceived by the human beings as pitch. Sound localization. It means to locate the sound from where it comes from. The ability to locate sound in our environment is important part of hearing. Each pinna, it interacts with incoming sound waves differently depending on the sound's source relative to our body. So, each of our ear interact with the sound waves in differently. And this interaction depends on the source of the sound. This interaction provides a monaural, that is hearing with only one ear, cue, that is helpful in locating sounds that occur above, below or in front or behind us. Then binaural. It involves both the ear. The binaural cues, it provides information on the location of a sound along a horizontal axis by relying on differences in pattern of vibration of the eardrum between our two ears. So, sound localization is the process of locating the sound. Here, the monaural and the binaural cues are used. The monaural cue, it helps in locating sound that occur above, below, in front and behind of us. And the binaural cue, it provides information along a horizontal axis. Now let's see the characteristics of sound. Intensity. It refers to the volume, whether it is high or low. For example, in a very quiet place, we may be able to hear a single leaf fall to the ground. Sometimes, if we go to bed and once we are settled, we may hear our blood pulsing through our ears. On the other hand, when a person riding a bike, he has his headset turned up, then he cannot even hear what the person next to him is saying. So, we all are familiar with this kind of loudness or the intensity of the sound. So, that is the intensity or the amplitude of the sound. Then, tone. It is a musical or vocal or a melodious sound with reference to its pitch, quality, strength or intensity. It refers to if the sound is higher or lower. That is, if the sound is of single frequency, it is known as a tone. And the intensity can be varied. It can be high or low, but the frequency, the single frequency sound, it is the tone. So sound is a mixture of tones. Then timbre. The spelling may be Timbre, but it pronounced as timbre. It is the tone of a particular sound, whether it can be an instrument or a person. For example, it is easy for us to recognize someone's sound when you are close to them. So that is the property that allows us to distinguish and recognize the voice or the sound of a person or an instrument is known as a timbre. Then frequency. We have seen that it is perceived by humans as pitch. It is a number of vibrations made in 1 second. For example, the voice of a baby, it is in high pitch, and the voice of a grown-up man is in low pitch. Then duration. It is the time of the vibration of the sound. How much time the vibration it lasts. That is the duration. Then what is psychoacoustics? It is a study of the human perception of the sound. Phases of auditory perception. The stimulus, that is a sound wave, it enters the ear. From there, the nerve stimulus reached the brain, and there the perception happens. And for the perception to be happen, the brain has to analyze the characteristics of the sound. We have learned what are the characteristics of the sound in the previous slide. Those characteristics must be analyzed by the brain for the perception. And this perception happens in several steps. First one is detection. It is the most basic part. The auditory stimulus or the sound waves, it has enough intensity to reach our ears. Then the sound must be within an audible range. So the sound wave must have enough intensity and it should be within audible range. Then only the brain will be able to detect it. So the brain has to detect from where the sound is coming from, and it can even tell whether the source of the sound it is moving or not. Then discrimination. It is the ability for the human being to differentiate the sound. So in order to perceive and to appreciate a sound wave, we have to be able to differentiate the sound from other background noise. So that is the second step, to differentiate the sound. Then identification and recognition. We have to be able to identify which sound it is, where the sound is coming from, whether it is a voice or it is a sound of an instrument or whether it is any other sound. We must be able to identify and recognize it. For example, if we hear a sound, if there is any personal relation to the sound, then easily we will recognize it. Like, oh, it's my friend's voice, like that. So, in order to perceive a voice, we need to be able to identify it as such and not confuse it with other sound. Then, comprehension. It is essential to understand the sound that we hear, whether it be a message, that is, someone telling us something, or the meaning of a sound, like the bell in a school that shows that class is over. So if a friend at a party is telling you that he has to leave, then it is important that we understand the message he is transmitting. So, comprehension. These are the phases of auditory perception. We need to be able to detect it, discriminate it, identify and recognize it, and comprehend it. Now let's have a quick recap on what we have learned. We have learned what is an audition, then the anatomy or the structure of the ear, then how the nerve impulse is carried to the auditory cortex, then how we perceive the pitch, how we localize the sound or the how to locate the sound, and then characteristics of the sound and the phases of the auditory perception, how the brain perceive the steps involved in the auditory perception. Hope you like this video. Please like, share and subscribe. Thank you and keep smiling.